Astronomers have pointed the James Webb Space Telescope toward the beginning of time, toward the dawn of our universe, and found something that, by our rules, simply shouldn't be there. In the nursery of the cosmos, just a few 100 million years after the Big Bang, there are objects so enormous, so absurdly bright, that they challenge everything we thought we knew about the birth of the first stars and galaxies. What Webb found is so strange, so unexpected, that scientists are being forced to think of an explanation that seems straight out of science fiction. The answer to this cosmic puzzle may lie in a type of celestial object we've never seen, a class of stars that shouldn't even be possible, the hypothetical and colossal dark stars. To understand what discovery this is that could rewrite the history books of the universe and, who knows, solve one of the greatest mysteries in science, stay with me until the end. And take advantage to subscribe to the channel so you don't miss any of the next news that the James Webb will bring us. To understand the size of this anomaly, we first need to understand what scientists expected to find. Our standard model of the universe, the so-called Lambda-CDM, works incredibly well. It tells us that the universe began with the Big Bang and since then has been expanding and cooling. In this scenario, the first things to form should be small. Think of this as building a city from scratch. First, small cabins appear, the most basic structures. Only after billions of years do these cabins come together to form villages, which then grow into cities, and eventually into the giant metropolises we see today, galaxies like our Milky Way. The logic is simple. Big things take time to make. The first stars, which scientists call Population 3, should be the pioneers, formed from the pure hydrogen and helium of the Big Bang. These stars, even being large, would be just the first building blocks. The first galaxies would be small and faint clusters of these stars. So, when astronomers pointed Webb's golden mirror toward this epoch, between 300 to 400 million years after the Big Bang, this is what they expected to see: cosmic cabins, small protogalaxies, forming slowly and gradually. But that's not what they saw. Instead of cabins, Webb found authentic cosmic metropolises, shining with a light that seemed impossible for that age of the universe. Using data from the JADES program, JWST Advanced Deep Extragalactic Survey, astronomers began identifying various objects that broke all the rules. Recently, the most distant galaxy ever observed was confirmed, JADES GSZ 14-0, seen as it was just 290 million years after the Big Bang. But it's not just the distance that's shocking, it's the size and brightness of these primitive objects. The problem is that, according to our models, there hasn't been enough time since the Big Bang to gather so much matter and form such bright and massive galaxies. It's the equivalent of finding a perfectly built Egyptian pyramid in the Stone Age. Something in our timeline, in our understanding, seemed fundamentally wrong. The scientific community was left scratching their heads. Could galaxy formation be much, much faster than we thought? Or does our main model of the universe need a major revision? Maybe. But a team of physicists, including pioneer Katherine Freese from the University of Texas, suggested an even crazier idea. What if those points of light aren't galaxies? What if we're looking at individual stars? Stars of a completely new type, powered by something that makes up most of the universe, but that we've never seen directly: dark matter. Dark matter is one of the strangest things in the cosmos. We know it exists because of its gravity. It's the invisible glue that prevents galaxies from falling apart. Everything we see, planets, stars, us, is only 5% of the universe. Dark matter accounts for about 27%. The theory of dark stars, first proposed in 2007 by Katherine Freese and her colleagues, says that the first stars in the universe might not have been powered by nuclear fusion, like our Sun. Instead, their energy would come from the annihilation of dark matter particles. Let's simplify this. The early universe was super dense, not only in normal gas, but also in dark matter. In places where gas began to come together to form stars, the concentration of dark matter would be extremely high. One of the main candidates to be the dark matter particle is the WIMP, and it has a strange property. It is its own antiparticle. This means that when two WIMPs collide, they annihilate in an explosion of energy. In dark stars, this process happening in the core would generate an absurd amount of heat. This heat would be so intense that it would prevent the complete collapse of the gas cloud, stopping the process that would initiate nuclear fusion. The result? A star that doesn't shine by fusion, but by the dark fire of dark matter annihilation. And what kind of star would this be? A monster. Without the limits of nuclear fusion, these stars could continue to accumulate gas and grow to sizes we can't even imagine. Models suggest that dark stars could have up to 10 million times the mass of our Sun and shine with the intensity of 10 billion suns. They would be bloated giants and, despite the name dark, would be incredibly luminous, especially in the infrared light that the James Webb specializes in detecting. Suddenly, the enigma of the JADES objects begins to make new sense. What if some of these points of light, like the candidates JADES GSZs 13-0, aren't galaxies of millions of stars that form too early, but rather a single supermassive dark star? Their anomalous brightness and size would be explained. A study published in the Proceedings of the National Academy of Sciences argues that the characteristics of these objects are compatible with what we would expect from a supermassive dark star. If this hypothesis is confirmed, the consequences are gigantic. First, it would be the first time we've detected, even if indirectly, the annihilation of dark matter. It would stop being just a theoretical thing with gravity to become something whose effects we can actually observe. We would be opening a window to the dark side of the universe. Second, dark stars could solve another big puzzle. How did supermassive black holes appear so early in the universe? Astronomers observed these cosmic monsters with billions of solar masses at a time when the universe was very young. By normal models, there wasn't time for them to grow so large. Dark stars offer an elegant way out. When the dark matter fuel of such a star ran out, it would collapse under its own gravity. The collapse would be so extreme that it would directly form an already massive black hole, which could then grow rapidly to become the giants we see. Of course, it's still very early. These JADES objects are, for now, candidates for dark stars. Most scientists still believe they are galaxies, just formed in a more efficient way than we predicted. We need more data from Webb to look for definitive signatures that can distinguish between the two theories. But the simple possibility that Webb has already found these primordial giants is spine-chilling. We are living in a golden age of astronomy. Tools like the James Webb aren't just confirming what we know. They're breaking our certainties, forcing us to think in completely new ways about the universe. What began as a point of light too bright in the infancy of time may be the key to unraveling two of the greatest mysteries in physics: the nature of dark matter and the origin of supermassive black holes. The impossible objects that the James Webb discovered may be the first evidence of a type of star that shaped the universe in ways we're only now beginning to imagine. But now I want to know your opinion. What do you think these objects are? Galaxies that formed in a way we don't yet understand, or the first glimpses of the colossal and mysterious dark stars? Leave your theory here in the comments. Let's discuss this incredible discovery. And if you were as fascinated as I was by this mystery, don't forget to leave your like, Share this video and, of course, subscribe to the channel so you don't miss the next chapter of our exploration of the universe.